In this video we'll be going over the continuation of the csharp.net video tutorials. So in this video we'll be continuing with the notes, so we'll be starting some notes for the second last chapter. So we'll be talking about inheritance and polymorphism. So I just have some notes, some multi-line comments here. So we'll just be doing a few notes, and mostly we'll just be speaking most of the time. So most of the, we might have some code examples. So pretty much the rest of the videos are in the C# playlist on my channel, csharp.net in the playlist. So we may be covering some advanced topics. Okay, so here we'll have, so we'll just say what we're doing. So here's inheritance and polymorphism. Okay, so inheritance and polymorphism, I may have done some of this stuff in Java. So it's an object-oriented programming concept. It's a little bit different in C#, but most of the concepts are the same. So inheritance allows a new class to extend an existing class. So for example, let's say your grandma dies or something and she saved you some necklace or some money or something. And in her will she wrote that when she dies she wants to give some possessions to you, some possession to your sibling or something like that. Maybe a cousin or niece or nephew or something. So that's the same idea. So inheritance is just basically you're passing on something to a child, or some kind of usually in inheritance so there's like a parent class and then a child class. So a parent class can usually have many child classes, but only one parent class. So inheritance allows a new class to extend an existing class. The new class inherits the members of the class it extends. So remember, class members are methods, fields, probably properties in C#, and maybe some other things. So you could have, and it can get confusing, you could have like a family tree kind of thing where the bottom of the tree is inheriting from like the very top seed. Like it's like a root of the seed. So there's like your tree, and then the bottom is like, could be like the roots. Actually, no, sorry. The roots, I guess, would be the top of the tree because that's where the tree comes from. Like the tree grows from the roots, and the leaves are like the children. So it's that idea. It's kind of tricky. Just pretend that you're inheriting from like a family tree. That's what it means. So whatever's on the bottom, you're getting from the top. So you have access to different. Basically, for security reasons, you may be able to access things. If you have like a parent class or a related class, if you're inheriting from a class, for security reasons you can access those, basically like you can access those members, class members, but for example other classes can't access those things, so therefore it's more secure. So the new class inherits the members of the class it extends. So it has to, in Java they use the extends keyword. So we'll talk about how it works in C#. It helps to specialize a class from an existing class. So usually you want to keep the classes kind of, for example, you would say like, okay, well the car steering wheel, or I'm not sure if that's the best idea. Or you could say, for example, like you could say the car steering wheel comes from the car class, and the car class comes from or inherits from, or extends the automobile class. So the automobile class is going to be at the top. So I'll just back on the notes here. So we have like automobile. Then we could say, for example, car extends automobile, which makes it the child of automobile. And then here we could say that like car steering wheel extends the car, and it's the child of the car. So in this case we have like a multi-generation inheritance. There's probably a special word for it, but pretty much the car still has access to the automobile properties because the car has access to the automobile property. So we'll be discussing that. You can also make it secure where the car wouldn't have access and all that. So we'll be doing some examples. It can get kind of confusing. This is just common our object-oriented programming stuff, so we'll be talking about it more in related to C#. So it can also help to generalize common members of many classes into a new class. Okay, so we'll be discussing this. Okay, so so the is-a relationship, like this, is-a. So they discuss this theory in object-oriented programming. So when one object is a specialized version of another object, there is an is-a relationship between them. So for example, you could say that the car is an automobile, or the car steering wheel is a car, which kind of doesn't make sense, but technically it's correct. So you want to make sure that it usually follows the is. So when you're creating your classes with inheritance, you want to try to make sure that it follows the is kind of rule that's not really a rule. It's not like a syntax, but you kind of want it to make sense. You don't want to go like, well, the TV is a car, because that wouldn't really make sense. The car steering wheel is not really a car, but it kind of is. So you got to keep that convention the same, I guess. Try to keep it. So it's just like a logic thing. So you can actually have whatever you want. So all insects, for example, can be described by an insect class. So you could say that a grasshopper or like ladybug extends the insect class. Okay, so pretty much just continued. The is-a relationship implies that the specialized object has all the characteristics of the generalized objects. So the specialized object characteristics that make it special. The specialized object has additional characteristics that makes it special, whereas a generalized object does not have those special characteristics. So this might not make 100% sense yet. So we'll be getting into some coding examples in a sec. So in object-oriented programming, inheritance creates an is-a relationship among classes when you declare a class to be a specialized class of another. So I guess in C# they kind of talk about specialized as well. So this allows you to extend the capabilities of a class by creating another class that is a specialized version of it. So pretty much when you inherit something, it just becomes more specialized. That's what the Microsoft Docs talk about. So base and derived classes. Inheritance involves base and derived classes. So the base class is a generalized class, and it is sometimes called the superclass. So this is also another theory. So you could say, for example, here, automobile is a superclass. Back on the screen, sorry. Automobile is a superclass like that, or is the superclass. And you could say that car is the subclass. That's also other terms that they use as well in object-oriented programming. So you may see a bunch of different terms. You may see like child, parent, superclass, subclass, something like that. So you can think of the derived class as an extended version of the base class. The derived class inherits its fields. Okay, so let's talk about this part. This part's important. So the derived class inherits fields, properties, and methods. So the derived class inherits fields, properties, and methods from the base class without any of them having to be rewritten. So the derived class inherits fields, properties, and methods from the base class without any of them having to be rewritten. So it's basically like a concept in software development that's, what's the word, kind of like efficient, because you're actually able to not rewrite code over and over again. It also helps you organize things like objects and all that, classes. So new fields and properties may be added to the derived class that makes it special. So I don't believe the parent class would know about those methods. You can always try and see if it works. I would assume you wouldn't really want to do it that way. So inheritance notation, I don't think it does work, but you can always try it. Usually the child will have its own methods that the parent wouldn't really know about in the first place. So for example, we could go with, so the notation is more of the C++ notation in this rather than Java, so there's no, I don't think there's an extends keyword. So in this case we'll just go with, so let's just go with something here, inheritance notation. Maybe I'll capitalize it. Okay, so here for example we could say that we have like a public class automobile. Again, just the same example. Open a block here. We have members, class members. To fields, methods, properties, in whatever order. Okay, so in C#, the general format to declare inheritance in the class header. So we've seen this before. Where have we seen this before? We've seen this before here. There's your inherits from. That's what I've usually said. Public partial class. I'll say Form1 inherits from form. So that's the symbol for inheritance in C#. So it's pretty much like C++. C++ uses that symbol for other things. But pretty much, yeah, so you just do it that way instead of a keyword. So pretty much in C#, the generic, just like the general notation is like this. So pretend we have another file. Then we could say that, for example, we have public class car. We could say that it inherits from automobile like that. Now automobile would have, now car would have access to all the automobile members, fields, methods, and properties. Well, pretty much all the members, which include the fields, methods, and properties. So car is the derived class and automobile is the base class. So you can also have words like derived or extended or different things. So this is the colon symbol, so the colon indicates that this class is derived from another class. The colon symbol indicates that the class, so the colon symbol indicates that this class is, that this, or basically that this, or that the class is derived from another class, or another, basically, yeah, so that's the superclass on the right side. So we'll talk about that in a sec. Okay, so we have here the colon symbol indicates that the class is derived from another class. So the one on the right is the superclass, the one on the left is the subclass. So we're saying that car inherits from automobile. If we flip these, then automobile would be inheriting from car, which doesn't make sense, but it could still work. The compiler's not going to know what the exact, like which way you're, if it's, they won't really know about the nouns and adjectives and all that. Okay, so examples, or not they, but the compiler won't know. So we have some examples here. So we have, for example, like a car dealership or something. So we could say that the car dealership keeps the make, year, model, mileage, and price as fields, or probably backing fields. So each type of the vehicle that is kept in inventory has, has the general data, and then each vehicle itself has specialized data. So there's kind of a theory here. General data is from the superclass. Specialized data is from the subclass. So now when you want to be more descriptive about your classes, then you can basically use inheritance if you want. If there's some kind of inheritance relationship, then you can have some kind of inheritance. You can create an inheritance relationship using inheritance. Alright, so this is going to be pretty much a example code. So some of the parts are just going to be missing, but it's just going to be pretty much just an example. So we'll just get started here in a sec. Just take a 30-second break here. So just get set up for pretty much just two classes. We're just going to do it in notes, not in the actual compiler yet. We'll be doing that soon in the lab. Okay, so I'm just going to actually just delete all this stuff here. Actually, even this stuff, the title of the slides and stuff. Okay, so here this is going to be the base class. So we'll have a class here, for example, public class. Well, actually, we don't really need to type this out yet. You can try to figure out which one's going to be the base and which one's going to be the subclass anyways. So public class, well, I didn't name it here, so we'll have automobile. And we'll say that it has some backing field, so we'll say that it has a private string underscore make, private string underscore model, private string, whoops, spelled it wrong. So private string underscore mileage, and private string underscore price. So these are our backing fields. Okay, so we could have a parameterless constructor here. So we can say that to call a constructor here, we're just going to call the class name. So public automobile like that, remember it's going to have the parentheses. These are just going to be empty like this, just to show that it has some kind of code in here. So we could just pretend that we have the properties. So for the base class, we're not going to go over it too much, because we've kind of done this stuff a lot. So here we'll just have like some property stuff. So here we'll have, for example, we have our public string make property. Then we have our public string model property. Then we have our public int mileage property. Okay, so then here we have our public decimal price property. And that's it. We're not going to fill these. We're not going to actually set up the properties because we know how to do that. If you don't know how to do that, everything's in the playlist. How to set up properties, how to use the get and set keywords, all that. The theories and all that. It's all in the playlist. csharp.net on my channel. Okay, so we'll use, for the next one, we'll go with derived. So we'll just have, so this is our class. The super class, it's done. Now we'll have the derived class. We'll just move this bracket up here. Go underneath, we'll just pretend we have another class here. So we'll have, let's space them out with a comment. So here we'll say public class car inherits from automobile, just like that. The syntax is going to be different if you're, well, it's not really a syntax, but instead of, for example, Java here, that says extends, the only difference is that we change extends to the colon, which makes it, it just means extends. So that just means inherits from, so it's the same thing. So public class car inherits from automobile. We'll have one backing field here. So for example, private int underscore doors. So we could say that we have like this amount of doors. Or here we could just say like car doors, like that. So we have this many car doors. Then here, for example, we could say that we have a parameterless constructor. So here, for example, we'll just, to call the constructor, we just reference a class name. Include parentheses, we said no parameters, so we'll just leave it like that. Actually, sorry, we're not going to leave it like this. We're going to go with, we're going to actually get the doors, and we could set it up to some kind of object. But in that, well, if we wanted to do that, how would we do that? Well, we'd add parameters when you instantiate the object. You could say that this object has this many doors. You could have said that it takes, for example, int doors. And then here we could have went with the backing field points to the doors. Or you could have just said car doors. Right, instead of that, we're just going to do something else. We'll just initialize the doors to 0. So here, for example, we'll just take the backing field, we'll reference it, so we'll see underscore doors points to 0, like that. Now we'll create the property, so we'll say public int, we'll call it doors. So we're going to call it doors, but we're going to capitalize it so that we can, because usually a property with Microsoft is going to be capitalized in C#. So here we'll say get. And here we'll say return. What do we want to do for the getter? We just want to return doors. For set, what are we going to do? We're going to take underscore doors, our backing field, and point it to value, like that. And here we can have like a pretend instantiation class. Or we can say that it's like the main form. So here, for example, we could create a car object in where we have access to these properties. Make, model, and price. So watch what's going to happen here. So we're going to go with creating a car object. We could say that we have a car points a new car. Then we could say that we have, for example, car.make. Points to, for example, Ford, and then here we could change this to car.model. We could change that to, for example, Mustang. Then here we could change the mileage, so we can go car.mileage. Points to, for example, like 1,000 miles or something, or kilometers. And then here we could have, for example, that we have car.price, points to some number. Alright, so we have pretty much, that's the main form with the object instantiation. So we have our car points a new car. Now we access the properties from the superclass, which is here, and we access those properties. Notice how the properties are in a different class, but through inheritance, because these properties are in the automobile class. But through inheritance, then we were able to access those backing fields and properties, pretty much just the properties. So we were able to access those properties, set them as strings. This one shouldn't have been a string here, so I'll just take that one out. Change it to an int. I don't think this one should have a string or string literal quotes around it as well. So that's pretty much it. We have two strings, an int, and actually we have two ints, maybe a decimal actually. So that's it. Notice how if we would have just taken out this, if we didn't pretend we didn't have this extend or inherits from automobile, then there would have been an error because we don't have any fields here that suggest that we have a make, a model, a mileage, and a price for properties. Great, because here we don't have any properties defined for make, model, price, or whatever. Make, model, mileage, and price. We don't have any properties set up for in the car class for those properties, but we're getting those from the superclass, which we have access to with inheritance, like that. So that's pretty much it. So that's just the end of the first part of the notes. In the second part, that's about half of the notes. So in the second part, might have to split it up into 3 because there's more long codes. But thanks for watching, guys. If you guys like the video, you can like and subscribe to support the channel for more programming and investing tutorials. In the next video, we'll be continuing with inheritance and polymorphism. The rest of the videos will be on my channel under the csharp.net playlist. So thanks for watching. I'll see you guys in the next one. Thanks. Take care.